You're welcome to Sequence and Series Class 4. I remain Victor Odigomore here. In our today's class, I am going to show us we are still talking about the application of this expression for an arithmetic progression. So we are still looking at the application in solving problems. So this problem, I got it from WAEC 2008 question 13. Okay, so I want to look at how we can, the question there say find the values of x and y. Okay, so how can one be able to apply this into this in solving that problem? Let's go. Now, if you check out this, I have explained that this first value you have here is called the first term, and the common difference is in between them. Okay, but if you watch here, you cannot be able to get the common difference between, because existing between here and here, the common difference is not known. Existing between here and here, the common difference is not known, but there is a way out. So you can say solution. Okay, so you say, you write the expression that Tn is equals to a plus n minus 1, then close bracket d. So what you do here is you write out this, that a is 3, common difference question mark not known, and then if you look here, this is 1 2 3 4. I think n, the term in number 4 is known, so you can say that T4 is 18. So with that T4 we can do something. So we can say T4 which is equals to, which is also embedded in this expression, is 3 plus 4 minus 1, then the common difference. So this T4 is 18 equals to 3 plus, this is 3d, because this, I know 4 minus 1, you know that is 3. Okay, so this means that if we collect the like terms here, this is just like just a simple equation. Okay, so we have 18, can say collecting the like terms, put that into writing. 18 minus 3 is equals to 3d. It then means that 18 minus 3 is 15, so 15 is equals to 3d. Divide both sides by 3. Okay, when you divide both sides by 3, obviously you're going to have 15 over 3 and then 3d over 3. It then means, as one can see here, that 5 is equals to d, or your d is equals to 5. Do we get that? Now you realize that now that you've been able to find that the common difference is 5, we cannot be able to go back here and use it and find the values of x, y, and that. Do you remember either in class 2? Yes, I was able to explain to us that T1 is A and T2 is A plus D. T3 is equals to A plus 2D. So it then means that since this is 3, this will be 3 plus 5. That's the common difference there. And this will be 3 plus 2 times 5. So here we have 3, 8, okay, and this is 10 plus this, that's 13. Okay, then that's to say this sequence, which is 3, x, y, 18, is the same as 3, and x is now 8, and then y is now 13, and then we have 18, and the thing continues. Do we get that? So this is the sequence that is derived, and we have been able to answer that question, find the values of x and y. So that's the application of that expression for finding the nth term of an arithmetic progression, or finding unknown values as the case may be. There's something else, one more thing I want to do here. Assuming this is the sequence that is given to you, and you are asked, in the last just concluded class, I was able to show you how this type of sequence can be given to you, and you are asked to find what will be the 20th term, the 30th term, the 50th term, and so on and so forth. I was able to show you how to use that. And also, secondly, I was able to also show you how to use this general expression to derive the specific expression that generates this. I will also do it here so that you can also see that there is not too much difference in both. Okay, assuming I want to find the expression that is generating this, specific expression that is generating this, because after this now, I'm going to take you to the next class where we're going to be working around rules, functions that are generating sequence, a particular sequence. Okay, so assuming I want to find out what is generating this, look at what I'm going to do. From Tn equals to a plus n minus 1, then the common difference here a is 3 plus n minus 1, then the common difference is 5. So what will happen is that I will have 3 plus 5n, okay, minus 5. Because 3 minus 5 will give us minus 2. So obviously, the rule that is generating this sequence is Tn equals to 5n minus 2. This is the rule. You can test it. When n is 1, 5 times 1 is 5. 5 minus 2 will give you 3. When n is 2, 5 times 2 is 10. 10 minus 2 will give you 8. When n is 3, 5 times 3 will give you 15. 15 minus 2 will give you 13. When n is 4, 5 times 4 is 20. 20 minus 2 will give you 18. Can you see that this function generates this? Where did I get it from? I got it from the general expression for finding the nth term of an arithmetic progression. I am trusting God that this class is good, has benefited you. We have looked at the application in solving a given problem. We are going to do more problems. We are going to do as many problems as possible. 50 of them, 100 of them, so that you can be balanced enough to face any. When you say you have passed through someone who taught you this, you can, you can be able to have assurance that you can defend whatever you are going to face as a question or as a problem out there. Thank you so much for being part of the class. I remain Victor Odigoma or here. You're welcome.